There's a new standard out from VITA. It's VITA 93 called QMC. And it's really a neat standard that I think is applicable not only to military and avionics spaces, but to industrial spaces where rugged peripheral expansion is needed. Mark, why don't you start us out and tell us a little bit, what is VITA 93?
Sure. VITA 93 is a new small form factor IO mezzanine standard. It brings basically the kind of the nice features of PMC or XMC in that it has a host side connector as well as a standardized IO connector. But in a much smaller package. It originated actually out of another relatively new standard, VITA 90 or VNX Plus. We needed to be able to add expansion I/O to a very small module. The VNX Plus module is quite small, too small for XMC or PMC. We looked at what was available on the market and as far as other I/O modules go, and none of them really worked, especially because they didn't have that standardized I/O connector. So we created a new standard, and what we found is it actually has quite a bit of applicability beyond just the original VNX Plus application that we were targeting.
So, what alternatives are there to QMC at this point? Something like M.2, for example, or maybe
Exactly.
Plus?
Exactly. Yeah, we did originally did a trade. We didn't want to start a standard if we didn't have to. So we did a trade study, looked at what was out there insofar as like M.2, mini PCIe. We looked at a couple of proprietary mezzanines that people have developed and market on their own. But none of them really kind of ticked all of the boxes. One of the most important things is that we actually wanted to have as much performance, IO performance as we could get from the standard. Most of the others that were out there, in addition to other shortcomings such as maybe lack of ruggedization, maybe didn't have the range of IO performance that we were looking for a brand new standard. So that's why we kind of created a new one.
Matt, you guys do all sorts of things with all the other interfaces like that. Can you tell us, contrast to what QMC will be with, say, M.2?
No, that's a great question, Bill. And I the biggest when I think about QMC versus M.2, I think of the fact that Mark mentioned QMC is obviously designed for VITA ecosystems, rugged ecosystems. M.2 is a great expansion port for general compute, but probably doesn't have the rugged features, the rugged interconnect, the small size, the scalability that QMC has. So the QMC ecosystem, through VITA 93 has really created a platform that's ideally focused for rugged computing applications. VNX, where it's smaller than FMC, it's smaller than XMC, it's faster. So lots of advantages that QMC has, not only over M.2, as you mentioned, Bill, but also some of the legacy mezzanine form factors like XMC, FMC, FMC Plus, and the like.
Mm-hmm. Okay. So, why is QMC important, Jan? It's obviously a new standard. Everybody wanted it for some reason.
Yeah, that's a good question. I think Matt already, or I think I want to connect with what Matt said, because with the VITA 93 standard with the QMC, as you said, that's a new standard that has been developed, and it's been developed for the growing demands in the embedded system market, and especially with a demand for modular I/O, addressing all the requirements for a high bandwidth, greater flexibility, and also the scalability, which is pretty important, as the need for I/O that's more modular, more flexible was just growing a lot. And the standard was also built on lessons learned from the previous form factors or previous standards. So it combines the best features from earlier form factors while also introducing new capabilities to not only meet the challenges we have right now, but it's designed for the future to meet the challenges that might come up. All that is also taken into consideration. with this form factor. And again, I think the key benefits for the new form factor are the scalability, as it allows to just have always pick the right amount of space needed for your I/O application, the modularity that you can just plug and play with and easily swap the I/O, the flexibility that is allowed with that. And then also, because a lot of other form factors that also allow that are not built for rugged systems, that's also a key advantage and why QMC is and will be important in the future.
Matt, why do you think QMC might be the best or maybe the only solution in certain applications? And what might those be?
I think we've, again, good question, Bill. I think we've highlighted some of the reasons for that. One of the things that I think, I know Samtech sees, and I'm sure Jan and John and Mark will agree, when you look at embedded computing, when you look at rugged computing, everything used to be x86 based. We're starting to see some FPGAs, but we're diversifying GPUs, you see ARM-based solutions, et cetera, et cetera. And, as you proliferate with these computing platforms, there's a need for high-speed I/O. x86, you can get native support, PCI 5. That's happened within the last year or two. It's going to continue to roll out across all these compute platforms. So having something small, having something rugged, having something flexible, have something scalable that can support not only PCI 5, but also a pathway to PCI 6 when that becomes native in the various compute platforms. That's where really QMC is going to differentiate itself. There's still opportunities, there's still homes for FMC, XMC, M.2, like we talked about earlier. But for something that's small, dense, fast, flexible, scalable, rugged, QMC checks all the boxes, especially when we start to see more of the intelligent edge and the need for I/O expansion within rugged computing platforms, like 3U, 6U, Euro cards, VPX, CPCI, CPCIe, VME, and more. QMC really is the only form factor that we see on the market that checks all those boxes.
Excellent. Well, to wrap up, I'll let everybody tell me, starting with Mark, what's the most exciting thing that you think about QMC?
Well, probably the most exciting thing is the kind of the new applications and the flexibility that it's going to introduce to the market. We designed it in the standard to be as flexible as practical, as well as being kind of rigid to a standard. So one of the goals we had was any QMC, any carrier. So you could, in fact, and there's a sort of a design criteria for both conduction cooling and air cooling. So you could, in fact, mix and match a conduction cooled QMC on an air cooled carrier and vice versa. But just the kind of the vast space of application and deployment that QMC supports is I think is going to be well accepted by the market.
Yeah, I pretty much agree with you, Mark, there. I just wanted to add the variable stacking height of the QMCs, where you have a variable stacking height, so you don't really lose the space underneath the QMC when stacking it on an SBC or anything like that.
It's small, it's fast, it's dense. That kind of summarize rugged. I think that kind of summarizes everything, and it really drives home the point of how important QMC is going to be for next generation embedded computing platforms.
Well, great. Well, everybody check out the other coverage we have on QMC, and we'll get into some of the more details later. Thanks a lot.